Yep.
Yep.
Yeah. So sorry, sharing wasn't working. So I was talking about in the Zoom, you can go to the chat and send message to the all panelists and attendee. And the school was established in 2013 November, and we're almost in business for 8 years. Right now, we're seeking for national accreditation and hopefully to get it this month or next month. It has been a 4 or 5 years effort. We'll be able to give student visa. We will be able to access Title IV 529 fundings for private school and college fund. So in Data Science Academy, we offer Data Science Bootcamp, also professional development courses. Right now, we are the only bootcamp teaching both Python and R. We have hands-on learning experience, and you will end up finishing 4 industry projects. And we offer job support for a lifetime. So a lot of students get their first job, coming back for the second and third job. Right now, we have over 2,000 alumni working across the global in data science related role. And we've been ranked as the top data science bootcamp for the past 5 years and 2 years as the best online data science bootcamp by SwitchUp. And we have a cohort starting next Tuesday. Sorry, this should be Tuesday. And depends on, are you working? Are you looking for full-time engagement? We offering like 3 months on site, which means you can take the bootcamp in New York City, or you can take the class remotely. We have students from South Africa, from UK, from Europe, all different continents to join our bootcamp. So if you're a working professional, a better option for you would be full-time or part-time online. So we utilize our classroom recording, and you can work and take the bootcamp, look for a new job. So we recently launched a new program called Data Analytic Online Bootcamp. So this one is less heavily loaded as our data science bootcamp, but this also helps you to transition into a data analyst position within 3 months. So if you are interested, definitely check it out. And the admission process is pretty straightforward. You start with submit an application, do a behavioral interview, do a text assessment, then you can be considered for bootcamp. And this is our website, NYCDSA.com. So the first option under the bootcamp is the bootcamp. The second option is the data analytic program. And if you don't know what you're looking for, you can go to our alumni page, look for people who have similar program background like yourself and where they land a job. So we have a very detailed page for all the alumni who allow us to do a photo and a video release on our website. So probably you can find 500 to 600 alumni information here. Okay, any questions so far? If no question, I'm gonna hand the floor to our speaker today to start today's event. So I'm gonna post this page in the chat so you have quick access to our offer. Thank you. Wenchang, you can get started.
Great. So if you don't mind muting yourself, that'd be great. Just so we are uninterrupted. Okay, great. So I'm muted, sorry. So my name is Wenchang. I am a bootcamp alumnus who graduated back in April 2018. Been working in the industry for a little over 3 years. And since then, I've been pretty much a data science engineer, working for small to medium-sized businesses, delivering end-to-end data-driven products. And I'm currently also building a startup called Tardigrade, helping entry-level job seekers with internet distractions and self-doubt to apply for a job together. So before I start this presentation, I want to give you some context and background of where the data science industry is. As of 2021, the fastest growing tech occupations is, let me just show you this graph. I think that gives you pretty good picture of what's going on in the job market and in the corporate industry. So top tech occupations is still software developer on number one, and that has not changed. But the fastest growing tech occupations and is now data engineer on top, which is fascinating to see. And we're talking about senior data scientists growing at 32%, still very fast, but a very fascinating trend to see is data engineering is climbing up. And you see backend developer, 38% growth, and talking about Python as a core language, Python developer 22%. You have DevOps engineer, a lot of DevOps engineer nowadays use Python, 21%, and backend developers, a lot of them are starting to use Django as backend. So it's a fascinating trend to see how things are shifting a little bit. And also another starking statistic is a lot of the projects, or as of 2019, 87% of data science projects never make it to production, according to VentureBeat. So what's happening is some companies or many companies are having a hard time delivering data science projects, pushing data science projects through the finish line. Now, and capital markets are sort of telling the same story. AWS makes the most money, and IBM Watson may sell Watson Health due to data challenges and unprofitability. Of course, that's just one company. Now, from my conversations with my network and industry, it seems like what's happening is that these companies want to hire, they used to just want to hire data scientists, more data scientists, but now they're blending the team mix with more data engineers. Okay, if you don't mind muting yourself, that'd be great.
I'm muting people.
Great, thank you. So that being said, the data scientist is still, among the fastest growing job sector. But if you synthesize all of that trend, the central theme is that we found out that AI models are sort of under delivering the hype and perhaps have been overhyped. And what's delivering the magic and not being overhyped is the data itself. So yes, models are important, but data science is and has been more about data and data solution than just models. If there is one takeaway from this presentation, it's probably just that. Okay, so now from my past 3 years of experience being a data science engineer and data consultant, delivering successful projects for the companies that I work with was how I was able to survive and build on my clients. I didn't have the luxury of failing a project and keeping my job at the same time. And through that, I learned tons. And this is why I'm here to do this talk to you as you're entering into the field. Hopefully, I want to share some of the lessons that I've learned in my past experience and from other sources, including books, conferences, and conversations with other industry professionals in the past 3 years, so that your future data science work can be perhaps a little smoother, easier. Lastly, as always, just please take what I say and what I tell you with a grain of salt, as your experience might differ from mine. So let's get started with the talk. And it will be a relatively long talk, as we scheduled 2 hours or so. We're 2:20, and so let's get started. Why this talk? Data science is hard, and having the right mindset and strategies makes it a little easier. And what do I mean by mindset and strategy? Okay, several points under each bucket. Mindset, we're talking about how do you manage your project expectation or ML expectation. Not every business problem is a CAG or competition. Data solution is a whole complex. Model as a service. Data science lives with infrastructure. Data science is engineering practice. Finish first, then iterate. Strategy, starting with interviews and existing approach. Labeling as a strategy. Going beyond existing data, the fluidity between model types, going beyond learning algorithms, not ML solvable versus ML unnecessary, test-driven development, building and owning your own ML pipeline. A lot of great stuff here, and we'll dive into each component in each section and talk more detailed about that. And by the end of that, we will have a quick review exercise, hopefully to kind of, summarize everything or synthesize everything, just so you guys have a better understanding of what I'm talking about. Okay, so before I dive into each point, I just want to talk a little bit about the life cycle, because it's hard to talk about these points before we have a good understanding of what a typical, data science ML project would include. From a business problem statement to a productionized ML system. So I just want to give a brief overview what the entire life cycle looks like for an ML project. And this is what it looks like. So we have probably, every company obviously does it, could be a different story. But, roughly it's about 3 phases. The first phase is about data strategy. We could be doing interviews, setting up business metrics, model metrics, building prototypes, developing a labeling strategy, doing some initial testing and acquisition of data.
This meeting is being
and second phase, we're talking about, basically, that's the phase that people are, hopefully you're quite familiar with. It's typically, doing some exploratory data analysis, feature engineering, model development, evaluation, testing, debugging, things like that. A lot of data scientists are quite familiar with that. The third phase is basically the production phase, the engineering phase, where you deploy your model, build up pipelines, monitor that, and perhaps retrain your model if the model performance declines, and so on and so forth. Okay, so that's kind of a quick overview of that. And the key points is, different size of companies might have different focus. For startups, you might heavily focus on data strategy. Okay, and that is something that's because startup probably doesn't have that much infrastructure, doesn't have a lot of people, and doesn't have a lot of time and resources to do a lot of heavy research at the same time while developing their own product. Okay, but on the other hand, if you work for a corporate, let's say you work for Google or Microsoft, then you're looking at a very different story. You might be joining their company and be like, well, the first phase has already been figured out for this project, and you're just there to maintain the project, maintain the model. And maybe there's new data that comes in, then you do some little bits research and development under number 2 phase, then you iterate through that. But the business case has already been established. The data strategy has already been done. So that's a very different focus. What's often overlooked is data strategy, and a lot of times this is where the trap is. You find out, especially for small to medium-sized companies, because they might have not dealt with AI or ML or even data as much, and they read some news and they're very excited about ML, adopting ML, and they go straight in and realize that it can't deliver what they want. They got burned, whatever. But data strategy is usually where it went wrong for that case. Okay, and then we have different patterns of cycles. We could have going sequentially from data strategy, development, and production, obviously, very logical step. Then iteration between second and third. Then we could have first phase to third, second to third, then iteration between two and three. I've seen that from Google's documentation. Google is very, very passionate about pushing their project ASAP through the finish line. Now, that might not be something smaller companies can afford to do. You might want to have a better product before you push it out to the market. But with the size of Google or Amazon, you can afford to push it out. Okay, and then you do iteration. When the data comes in, more people use your product, more data comes in, then you iterate your model, your project, your product in that way. Okay, so of course, I'm just giving two examples, but again, many companies might do it, a little differently, but that's kind of the general sense of what's going on. Okay, so and out of that, each phase, we could be looking at starting from defining a business problem to interview domain experts to, incorporate domain knowledge, define project goal, business metrics, building prototypes, labeling strategy, data acquisition. We talked a little bit about that. And what's very important to keep in mind is that, this is when you want to fail. Okay, and I said it here, basically, if the solution fails, stay at the current phase to find alternative solutions instead of proceeding to the next phase. This is where you want to fail, because the following stages, the following phases are very expensive and costly. This might be a couple week process, or I don't know, for a smaller company, could be even shorter. But this is where you want to fail, and this is where you want to talk to a lot of people, talk to a lot of stakeholders. We'll talk more about that in terms of how you can interview people. And this is where you test, like, is this project even feasible, right? Because you don't want to get to the third phase and you deploy it or end of second phase and realize, yes, you do have a 90% model, but it's not useful. That's not where you want to realize, or when you want to realize that it's actually not useful to your business case. Even though you build a fantastic model, but no one, or it doesn't generate business values. And this is where the 2019 stats come in, right? Hopping over 80% of data science projects don't go into production. Well, guess what? Data strategy. Okay, so don't dive into models or ML models right away. Okay, so, and this is the second phase that we talked about. I hope everyone is pretty much familiar with this. And it's something that most people talk about in the data science field, right? The third phase is, I changed the slide a little bit from the last time I gave this talk. It's the engineering phase. You want to have kind of a continuous integration, continuous deployment. And this is where the industry is heading towards. And many big companies have already adopted this for ML pipelines. You have basically, ML pipelines built up already, just like DevOps, right? Now we have data ops or ML ops. And that's kind of the emerging new profession that people are talking about. We want to version our models, we want to deploy our models, in a container, and serve it, monitor it, maintain it, and so on and so forth. But it needs to be, pipelined and engineered. Now, a lot of engineering happening in this place. And again, if you're in a big corporation, you might not be the person who's doing that if your title is data scientist. Okay. And if your title is machine learning engineer, I don't know, but if your title is ML ops engineer, you're certainly doing it. Okay. ML engineer, you might be doing a little bit of that, but in a smaller company, you might be doing this, depending on where you are, obviously. So you might be wearing, different hats and stuff. Okay. So this is ML pipelines. All right, let's dive into each of the strategy and mindset after we got to know, the entire life cycle and what's going on throughout the project life cycle. Okay, so let me scroll down to my notes. Okay, managing project expectations, or ML project expectation. A data-driven product, unrealistic expectations is ML everything. When you're fresh out of the field, at least I wanted to ML everything. That was very much unrealistic thoughts, and I quickly realized that. Now, a more realistic expectation is everything else is done with engineering or human, and you only have very small components that are done by ML. And again, there could be very likely cases that you don't need ML at all. And we'll cover those and what those cases are and what you can do under those scenarios down the road. And when your product becomes more complex and you collect more data, then you can do more ML. However, it's important to just keep in mind that ML could just consist or comprise of small components of your entire project, and everything else is done with engineering or human. Okay. I want to stop here because I haven't stopped, I guess. Any questions up to this point? I know some of you are students, some of you are joining us, outside of the bootcamp, but ask any questions if you have anything.
In the chat, Jasmine asked, can you explain the difference between data scientists versus data engineers within industry?
Fabulous question. So data scientist is someone who uses data to solve a problem, okay? And data engineer is someone who builds up data pipelines for data scientists to use the data. I hope that's clear. So basically you're engineering different pipelines, you're perhaps building, an engine to acquire data. Perhaps you're doing, Spark streaming job and building up a streaming pipeline so that all your tweets, can flow in a streaming fashion. You could be also, just doing a lot of, cron job, could be, right? Scheduling tasks, scheduling your ETL pipeline, which is extraction, transformation, and loading, but data scientists spend more time using the data. So data engineers don't necessarily use the data. Now, I do want to mention, so in some companies, and they want to just like, hey, we don't want to spend money on both data scientists and data engineer. I just want to hire someone who knows both, or a little bit of both. And then typically, what you're looking at is someone with a title called data science engineer. And that's kind of where what I've been doing. I've been doing, a little bit data science, a little bit data engineering. Okay. And basically that's when data scientists started building a little bit data pipelines as well. Okay, so the titles are not necessarily, A or B. It could be a little bit both, depending on how big the company is and how they want to structure everything. And I think, that's personal opinion. I tend to think that data scientists should actually build a part of the pipelines as well, because they're the ones who use data. What I've seen is that if you hand all the pipelines to data engineers, they end up building something, that's super cool, but it's a little bit hard to use. Okay, so let the people who use the data build a little bit as well. I think that's very helpful, because what I've seen is that you could have some data engineers building a lot of ETL tasks and pipelining all the data into a data lake, a database, and then you realize a lot of things are very messy, and the database becomes overly complex. And then a data analyst or data scientist ends up spending a lot of time trying to understand and maneuvering all the data tables that data engineers created. So it's really it's hard to balance that, I guess, when you separate tasks very clearly. Only one person builds pipelines and only one person uses data. So that's that. Is that clear?
It is. Yes.
Great, thank you. Okay, so next slide. Starting with interviews and existing approaches, communication is important, but how important? I think someone, Harvard Business School did a survey 2018. I think a lot of data scientists at that time ranked PowerPoint skill more important than deep learning model building skill. Now, at that time, deep learning was still not used as much. Now, over the past 3 years, deep learning has been, more widely adopted, but still not, heavily. A lot of companies are still using traditional machine learning models, but nevertheless, PowerPoint skill or communication skill or business communication skill is still super, super important. And in a lot of times, what I found out is that there's a huge gap between the business professionals and the tech professionals. Okay, and I'm someone who can fill that, and I'm someone who's trying to fill that gap. But a lot of times, when you're in the team, if you're a data scientist, if you are a data engineer, if you can wear a little bit hat, wear a hat, in terms of communicating between, the business folks and tech folks, and your team doesn't have a project manager, that's, where you can contribute a lot of values, because, that communication gap is certainly very wide. Okay, and it can cause a lot of troubles down the road with your project, and you just don't want it to happen. And let your supervisor, clients, stakeholders tell you what they want. Loop their feedback into the iterative process. And domain expertise sometimes needs to be incorporated as early as possible, and you need to develop the right questions to ask. Okay, and let me see if I can find some of my notes here. Ideally, you want to talk to people constantly, when you start a project. For someone who will evaluate your project, it's good to showcase the project by phases to get directional feedback. It's also essential to talk to the people who will eventually use your model. Okay, they're the stakeholders as well, to understand their thoughts and their current experience of completing the task. And if your product faces retail customers, you want to eventually design your product in a way that will loop back the customer satisfaction data. That's usually the best label. Now, basically, your model strategy gets woven even into the product strategy. Now, in domain expertise, and interviewing is an important task that I typically start for, that's where that's where I start pretty much for every data science project. I was just pitching, a project to a client, and I was constantly asking questions, confirming these assumptions that I know will validate or invalidate the project, and that is. Okay, if you don't mind muting yourself, that'd be great. And basically what happens is, you and even when you just check in with the clients, you want to make sure you validate these assumptions. And a lot of these assumptions are very important to ask before you dive into it. And because you don't want to be like, hey, sorry, this assumption didn't check and we can't finish the project in the middle of the route. And, you're kind of screwed at that point. So that's also very important to know. And let me see. And there can be cases that you don't know what your boss really thinks until you ask the right questions. But what are the right questions? So you usually want to ask what factors really go into the existing approaches. So ask that person to walk you through that existing process, very, very important. And are there any human decisions, right, which are potentially not solvable by ML? Those are very important. And what is the business metric in his or her mind that really matters for this project? This can potentially determine the success or failure of your project. And last point is, what's existing is what has worked, and what we are going to develop might not. Building on what's existing is what will de-risk the project significantly. And that is always the case. A lot of times, we data scientists, data science engineers, we're just, good at rebuilding things, right, from scratch. But usually that's not what the business wants. They don't want to start from scratch, and they don't want to, because of costs, anything, but, you should adapt to that and build on what's existing and have people walk you through what's existing, and you can identify each of the component that's automatable, solvable by ML perhaps, or by any other engineering methods. Then what's the rest of that, perhaps you should just leave that alone. Okay, so someone shared a link. I don't have time to click into that, but thank you for sharing. Business problem, customer segmentation, domain expertise interview. This is a good example, I guess. Ask marketing professionals on what factors do they currently group customers, and those can become important features. And manual heuristics, you could be starting the project from sorting and filtering instead of jumping right into customer segmentation as a model. And potential data solution is, hey, instead of using clustering that's hard to measure, maybe start with classification with labels generated from heuristics. So that's one way of doing that. Of course, there are different ways of doing customer segmentation. Okay, so not every business problem is a Kaggle competition. Okay, and oftentimes when we go through data science education, we start with Kaggle competition, which is great. Has tons of great stuff to learn, but it counts only a part of the ML project life cycle. A business cares more about business metrics and model metrics, and ultimately business metrics are the only metrics that matter. And define business metrics as project goals. That's also very important. Oftentimes you need to have a solid understanding of what business metrics really are. And if you don't know that, ask questions, interview people. What are those business metrics, that are important to your business? Or you should ask questions, ultimately, as long as you work for a company, business metrics are the only metrics, as I mentioned on top. And a lot of times the business executives you know, I hate to say that, but they just don't care as much about the model metrics. They probably don't understand it as much as you do. But what they do care is, you know, how can they get to what they want, right? And that's the business metric. And, you know, which could be eventually converted to top line figures or bottom line figures, or some metrics they can report to their supervisors. Okay. And the last point is very key point, which is aligning the business metric and the model metric. And oftentimes, you know, what happens is, you know, they're not aligned. Okay. And because and this is when you realize, hey, your model is not delivering the business value that people are seeking, and that's not good. So when you align that, you should, you know, and this is a great example of pitching a project, and this is how a great tool like AI Project Canvas, which I got it from reading an article, can help you to align this better. You know, this is a project that's called anonymization, and you know, then it lists out different components of that project. Basically, it anonymizes the data for your computer vision tasks, and you can have a 10,000 label images from car perspective, and data set. Is there a data set not available yet? Okay, maybe we need to acquire data sets. And what's the skill needed? Computer vision, Python, data engineering, output 95% accuracy, value proposition. This is where the value comes in, right? Protect privacy, enable data collection for function development, integration, microservice, offering anonymization, endpoints. Who's your stakeholder? Legal and management department, okay? And customers, driver assistants, function developers. And what's the cost? One FTE, one full-time employee for 3 months, image labeling, cloud computing, and revenue type SaaS revenue, software as a service type of revenue. Okay, that's a great way of kind of aligning, you know, your business value proposition and your model, you know, metric. Okay, any questions for these talking points? Okay, so I want to get a sense, Martina, I don't know if you're here, but is everyone here, has everyone here gone through this Zillow, Kaggle competition with Amos, Iowa?
I know that our students usually do this project, but not all of them.
Okay, and I guess the students here have gone through that.
Not all of our attendees are students, but
okay.
Most of them, yeah.
Okay, so
Yeah,
I just wanted to give a thank you. I just wanted to give a comparison between what a Kaggle project is. And let me just Google Kaggle project. Oops, Kaggle project, Amos, Iowa. Okay, so this is something, I guess, you know, it was probably not the original one, but something like that. And you have a leaderboard and you have some scores, accuracy, whatever it is, right? You have a score here. And I guess this is regression task. But what you're looking at here is, you know, how Zillow is using, you know, a similar model to predict housing prices on their website. And what's very interesting is that if you zoom in enough, you will see all the pricing tags, you know, on that. And this is kind of, you know, how they are predicting the housing prices. And if you zoom out, it's not there anymore. Okay, and it's just a red dot. Okay, now that business use case is very helpful, right? Because you want to know if you're a property owner in Amos, Iowa, and you want to know what your price is, right? Your property price, and that's very helpful when you zoom in, right? But what's happening here is, it automatically pops out. And so something like that probably has already been stored somewhere in a database, and it's just querying that. It's probably not doing an on-fly prediction. Okay. And so the latency requirement for this is probably not, very low. Okay. And we can pretty much, let's say this gets pretty, I don't know how they update it, but it could be updated every day, every week or so. Maybe, every couple of weeks, this gets updated. And property values don't shift as much as stock values, right? And so, and when you zoom in, the price value is not changing. Okay. So, but as you can see, to get from a prediction from a regression model to something here requires a lot more thoughts, right? Where can I put that model even in a business like this, Zillow? And how do I render that data? And what's that model serving in terms of business purpose? I think this serves great purpose of driving the traffic, right? Because a lot of people would want to know what their property value is, and they can just zoom in and see that. Okay, and the other way of using that model is, hey, I have a home index that I can put the values on and be like, hey, the average of this is 259,000. And out of the past year, we got a 5.6% growth. Great. If I'm in Mississauga, I'm happy to know that. Okay, but that is an aggregation of the predictions, right? Of the predictions that the model has made, right? So, and you have this 1 year forecast, no data. Okay, but if we do a forecast, that's another, perhaps a time series model, right? Okay, so you see where, these models are almost woven into a product as its product strategy. And that's very important to know. CAGO is just a component of the entire life cycle. There's much more to that after you're done with the with your model evaluation. So let me get back to my slides. Okay, so time 2:52. Okay, so I need to speed up a little bit. Business problem. I'm sharing a couple examples here. Video recommendation. The business metric could be, hey, we want to increase ad revenue generated from the video platform. And the model metric is what? Video click-through rates. And so how many videos have been clicked out of all the videos that were recommended, right? That's a video click-through rate, CTR. And, if I increase that, I might be able to increase ads revenue. Another one could be longer time spent on platform with satisfaction. And model metric could be video fraction playthrough percentage. So how much of a video is being played through instead of just clicking through, right? We've all watched, videos with clickbaits on the title, and we're like, this is not what I was asking for, switching to the next video. But video fraction is something that calculates how much video you actually watch through. So that's a more accurate metric of how people like that video that was recommended, I guess. Okay, so I'm seeing some chats. Should you jump in slides? I have to leave it 3 people. Okay, well, these are not transaction prices or asking prices. These are predicted prices by Zillow. And that's why I was like, that's the model that people are using, right? Within Zillow. And yes, I think Martina might be sending out the slides when we're done.
Mm-hmm.
great. How accurate is Zillow pricing data when using Kaggle? Kaggle, I believe people are reaching, I forgot what they what people were able to reach when using how accurate is pricing data. Zillow is pretty accurate. Okay, Zillow, Zillow, they are able to get it to like 90, like 5 plus minus 5%, something like that. No, that's pretty damn good. I don't know how accurate can the Kaggle data set get you. It's a small data set for Ames, Iowa. It's about 2,000 plus lines, rows of data. Okay, so I'm gonna skip this because we need to try to finish this on time. Okay, labeling as a strategy. You know, in real world, unfortunately, you know, your labels might not be given, and you don't even know what labels could be good for your model. And so, you know, labeling becomes a question that you need to solve. Okay, again, unlike a Kaggle competition, label is given. They know this label works and it's given to you, and you know that's the label, and you just train the model on top of that. That's that. So, but that's not the case in a lot of business scenario, especially startups, right? You're trying to solve a relatively new problem and that no one probably has solved before. And dang, you know, what's the label? So, and try to stick with supervised approaches. Unsupervised approaches are hard to measure and evaluate, but they can be good for EDA, explorative data analysis, or future engineering methods. Therefore, most likely you want to stick with supervised approaches in a business environment. However, it doesn't mean unsupervised approaches are not used at all. For example, topic modeling, super effective technique to extract keywords for messaging purposes in the marketing field. Okay, and I've used that for my work. That's an example of unsupervised approach. And we have, you know, so when it comes to labeling, we categorize labels as strong labels, weak labels, and no labels. Strong label just means it's a measurement directly related to your business metrics. Weak label means it's a measurement somewhat related to your business metrics, but not directly. Okay, and I don't have to explain no label because that's self-explanatory. And usually you only have weak labels or no labels in small to medium-sized business. So that makes ML extra tough for smaller companies. Okay. Providing two business problem case. One is evaluating web page performance. Another one is match people intelligently for networking purposes. For the first one, strong label could be direct satisfaction feedback, usually not available, right? And you know, how do you know people are very satisfied with your web page unless you provide, you know, are you satisfied with this? And people might click that. It's possible. But weak label could be, you know, average time on page. Okay, that's a weak label. You know, how much time people are spending on your web page on average. Now, when you don't have label, maybe install Google Analytics to track your website page, and so that it will give you this weak label. So that's one way of doing that. Match people intelligently for networking purposes. I'm giving an example of Lunch Club. You know, I'm seeing that. Of course, I don't work for Lunch Club, but I saw that, which is very interesting. Strong label, direct satisfaction feedback. Weak label, existing LinkedIn connections. No label, generate satisfaction ratings from product design post-introduction meeting. So for those of you who have used Lunch Club, let me log into my Lunch Club so that you will see. I haven't used it for a little bit. I have to log in, so I don't want to log in. Let me see if I can find an image. Lunch club. Okay, so I think, let me see if I can just let them send me a login link. Okay, great. So I have not used that for a little bit while. So this is a good example. Would you like to meet someone like Ross? You know, and the question is, would you like to meet? It's not would you like to meet Ross. It doesn't mean that they're going to match you directly, right? But someone like Ross. So that's a label to ask you so that you can label for Lunch Club and it becomes a part of their product strategy. And that's a good example. And if you work for companies like, you know, Lunch Club, or I don't know, you know, for other web platform companies, this is a great strategy to adopt. Of course, you need to be smart in terms of when you ask that question in the entire user journey, but that's a way to generate label. Okay. Going beyond existing data acquisition strategy. So we talked a little bit about that. You know, you can embed something in your product to generate labels, and you can also have other ways to generate data. And for startups, this is really heavily emphasized as they typically don't start with much data. And for marketing, which I've had some experience in, is also heavily focusing on data acquisition strategy, as marketing professionals need to seek innovative ways constantly of measuring customer behaviors and activities. And you know, when you work in a company, data sets are generated, and your first data set is usually not enough. So just like models, your data set should evolve as well. So you have to constantly, you know, evolve the data set to incorporate perhaps more features that are helpful. And that's important to keep in mind, you know. And there's a tool that's very cool. It's called data set versioning control. It's called, it's basically abbreviated as DVC. So this is DVC, open source version control system for machine learning projects. And this helps you to version your data sets, you know, a bit better. But sometimes I might just be using a timestamp as my version of the data. If that's saved, you know, if I use the SQL database, sometimes I might just use a timestamp, and that could be sufficient depending on your use cases. And save the old data, right? And also back it up in S3 buckets. Fluidity between model types, fascinating topic. And we're talking about, you know, a lot of model types are not fixated, okay? They can convert to each other depending on your use case. Again, you know, talking about product strategy. And it's a good mentality to have. One of the common strategies is to, you know, look at your product need and business need and be like, hey, can we convert this model type to fit into that product strategy? Okay, some of the questions that you could ask yourself is, how do you convert a regression model into a classification model? And why? Right? And how do you convert a classification model to a knowledge extraction task, classification model to recommendation, generated model to recommendation? And, you know, you have, you know, bunch of types models that you can choose from, right? And I put it here, ML solvable. And those are typically the models or tasks that you can perhaps solve by ML models, and they're known models. They've been developed for a long time. Some of them, regression classification, knowledge extraction, recommendation generative, and let me give you a couple examples. Regression to classification, why? Business problem, price forecasting, model choice, classification over buckets, / categories of price ranges versus regression prediction for a single price. Benefits, probability distribution, and actual model interpretation. So for example, if I just want to do stock price prediction, and I want to know how likely is my stock going to pass over $80 a share. And well, guess what? I don't need to know whether it's going to, go over to $82 or $83. It doesn't matter to me. What matters is I just want to know, it's over $80 and I can, put a ticket there. As soon as it reaches that, I just want to sell it. Fine. But then, that might be a good case for classification instead of regression. Instead of predicting the price, predict whether it will go over $80 a share. Okay. And it gives you probability distribution as extra model interpretation as a benefit, which is cool. Okay. So let me see if any questions. With respect to how can true response, clean and true response with methods are there out there to clean and honest and true? Yes. So survey responses are super dirty. Okay. So you need to basically regulate that, and a lot of times, if it's generated on your platform, that is a better quality already. But if you generate it from a survey collection platform, that could be very dirty. And you want to make sure you work with your survey collection platform, work with them closely. And, I was, that was actually what I had to do. I detected there were so many duplicates and it was not doing well. The data quality was not as good because there were just so many duplicates. So we had to work with the data collection platform to dedupe that and get to the actual responses and detecting that. So you almost have to do some simple filtering to detect, hey, there's no way a person can respond within a timestamp of a second of 2 responses, right? Because you can't respond 2 times within 1 second. That's not a good response, or it could be a robot. So filter that, right? So these things are data quality checks that you need to actually engineer and code, and to filter that to improve your data quality. Does that answer your question, Yanis?
Yes, great response. Thank you.
Thank you. Great. So do I need to talk about this? Okay, let's skip that. Stacking ML with other algorithms, optimization algorithms, it could be also search, routing, network. I've done, projects where I had to stack ML with other algorithms. And don't fixate your mind just on ML algorithms, because there are tons of algorithms out there, and ML is just one of them. Okay, so one good example that I have used is called something like this: Google OR tools. And it's an open source software combinatorial optimization. Okay, and it provides a bunch of routing, scheduling, bin packing. Fantastic tool that that's open sourced. Okay, and this is something that you could stack with ML algorithms. And so that's an example. All right, so network, another great area. that you should absolutely look into if you're dealing with a lot of people's data. If you're dealing with people, if you're dealing with, NLP, network could also be helpful in some cases. If you're dealing with search behavior, that could also be helpful, to visualize how people are searching, and things like that. Okay, so next one, 23. Okay, so now we talked a lot about algorithms, solutions, ML. What happens when you can't solve it with ML? Or guess what? They don't need it, right? That's the real world scenario. A lot of times, people just don't need ML and they don't realize it. And you need to tell them, you need to tell your boss, you need to tell your client that they might not need it, or this is not solvable. Because what I've encountered is that many times people just want ML. I just want to make something cool. I just want an AI model. I want an AI this and that. Well, sorry. And you need to tell that story earlier on, instead of later. So couple scenarios, couple situations that are not typically solvable by ML. Well, first of all, no such data, no sufficient data. Second of all, no existing algorithms available for such problem. Human decisions that are out of your control, not able to meet a product requirement standard. Maybe your product requires XYZ latency. Well, your model might not be able to meet that requirement. ML unnecessary. Only analytics is required based on business problem needs. So the client just needs a dashboard and they don't need anything else. Don't try to add ML on top of that, I guess. And another scenario could be only automation is required based on business problem needs, and client just wants a report with tables to be automated. And this is very common with many small to medium-sized businesses. They could have gigantic reports with tons of Excel tables, and identify what's automatable and what's not automatable is a task that a data scientist should have in their mind. And oftentimes the rules of thumb is what's repetitive is what's automatable. But what's automatable it might not be worthwhile to automate. That's also very important to keep in mind, because a lot of businesses could have tons of things that are repetitive, but they might not cost them as much time. So you might not want to automate that, but identify something that's highly repetitive, okay? And it's to a large scale, meaning they're doing a lot of that. So that's almost like an equation. If you times that, the repetitiveness times the scale, and that's the worth, your project's worth or value. And that's kind of how you want to pitch your product or project, right? Okay, so ML not solvable, ML unnecessary. I'm providing some examples here. ML not solvable. Okay, improve existing analytics process embedded with many human level decisions, often the case. Potential non-ML solution, identify the decision driven by human beings via interviews and leave them aside, test whether what's left can be solved by an ML solution. If yes, proceed. If not, then test the non-ML solutions. ML unnecessary, make the existing analytics process more efficient. Tons of companies just want to do this. Automate ETL process and produce an analytics dashboard with the existing tools. ML might not be necessary. And there's tons of projects just on this. Super effective, but no ML necessary. Okay. So I want to pause here. Any questions? I know we're going a little fast because we're trying to time the session. Any questions? Okay, so let's move forward. Data solutions as a whole complex. This is a super important slide. And in the end, you realize ML is not the only data science solution, and you realize there are a couple other solutions out there, and they're not totally independent to each other. They're a whole complex. And let me zoom in a little bit. So we have data analytics solution, automation solution / engineering, and we have the application solution. You know, it could be web apps, mobile apps, whatever. And data analytics solutions would include dashboards and reports. You know, you would see that perhaps in, you know, many companies. And you see that often now. You see a hiring pattern. People just hire one data engineer and one data analyst. And then you can produce this already, right? Just one data engineer, one data analyst. You don't even need a data scientist to do that. Or you could just hire a data science engineer and just build the entire thing instead of hiring 2 professionals. So that's a hiring pattern. And so, you know, automation solution, we talked about that it could be just some reports needing to be automated, some Excel spreadsheets. You know, a lot of corporations still deal with tons of Excel. You know, how to automate Excel stuff and build an ETL process on top of that, maybe. And automation solution, application solution. So in the end, you know, perhaps you work at a startup and, you know, you are building an application solution. But, you know, in smaller companies, you could have this too. You know, as a web app, you know, maybe some business folks just want to click, and you just deliver a simple app that, you know, incorporates these, right, data analytics and automation into that web app so that, you know, other folks, other professionals in your company can utilize that. And that's also a very common pattern. And what you realize is that algorithmic solution can power each of these, but it doesn't have to. Okay, the key point is it doesn't have to. Again, you know, going back to ML unnecessary, ML not solvable. But if you can find a use case, then these 3 become much more powerful, right? Okay. Model as a service, model deployment, make it accessible with API, mass as a business model as a product via API, Google Cloud, IBM Watson, AWS SageMaker. And so a lot of these companies have these, you know, off-the-shelf models, right? And, you know, what does that mean to a data scientist, right? I would like to quote from a talk given by a data scientist from Google AutoML. It's not replacing data science. Rather, it means data science that doesn't start from zero. So let's say you have been dealing with tabular data and somehow you need a well-known off-the-shelf algorithm solution from NLP to handle some text data. Well, you simply, you know, let's say sentiment analysis. And well, you simply don't have time to pick up NLP right on spot. Therefore, you should consider these APIs or AutoML solutions instead of trying to train the exact same model and find out you can't beat Google's model. Well, I can tell you that happens to many professionals out there. Unfortunately, you know, this is something that to be avoided, you know, because in the end, you know, it's, you know, we should be more open-minded to these solutions. That's the bottom line. It doesn't make you a worse data scientist. It just becomes a tool in your toolbox. Okay. And okay, so let me see. Yes. And again, this is a business model, right? So people not just sell apps. Nowadays, you could sell models, right? And also nowadays we're moving towards a new trend of selling features. We're talking about feature store, right? So it could be a feature as a service instead of model as a service. And that is an emerging trend that we should all watch closely. Okay, so data science lives with infrastructure. Data science is actually infrastructure heavy. And in the end, you will realize if you are not in the field yet or you're entering into the field, every component of the pipeline needs to deploy it on the cloud. And when you learn data science or when you try to master data science, it's probably very helpful if you do that along with infrastructure rather than doing everything on your laptop and then having to learn all these infrastructure along the way. You might as well just do it on these infrastructure. And a great book on this topic, which just came out a couple of months ago, is called Data Science on AWS. Let me show you this book. And and they have workshops. I was just talking about in the meetup that I host. Fascinating book. Let me read the subtitle. It's implementing end-to-end continuous AI and machine learning pipelines. So, and they have very practical examples of how you can deploy models and how you can build pipelines and MLOps solutions with using, the SageMaker's ecosystem. And SageMaker now is very big, and SageMaker has its own pipeline tool. And not only you can deploy your model on that, you can monitor your model on SageMaker, and you can build API connecting to your served model on SageMaker. And now there's AWS Clarify as well to monitor your model and generate bias reports, which just came out, I think a couple months ago, maybe at the last AWS reInvent event. So AWS SageMaker Clarify. It's a bias detection and explainability tool that's integrated into the SageMaker system. And this is some of the charts. Some of the charts look like difference in conditional outcome, conditional demographic disparity in labels. And it allows you to generate reports, which is very helpful and convenient. So try it out. It's very helpful when you first learning a lot of data science, and because everything needs to be deployed eventually. So you might as well just do it on the infrastructure, on SageMaker, and trying out different tools and ingesting data, not from your local laptop, but from like S3 buckets, RDS, SQL database, Athena, very cool tool that directly connects with your S3 buckets, and use SQL query to read your S3 bucket. So if you have a bunch of CSV files, clean CSV files in your S3 bucket, you can just connect that to Athena and read that directly. Very, very helpful. A lot of times you reduce costs in this way because you don't have to constantly have a database hosted and pay that instance time instead of, just paying it price per query. Infrastructure as code, again, very important. Nowadays, I try to provision my S3 buckets or, launch ECS plus Fargate cluster via code instead of just doing it from platform, from the AWS console. And, a lot of times infrastructure as code becomes probably a better practice in some scenarios, I would say. And because then, then you can version your code, right? And also it's more scalable, right? You can spin up multiple resources instantaneously and without you clicking through the AWS console. Okay, so any questions? All right, so data science as an engineering practice, I think it is, okay, someone, is infrastructure covered in the bootcamp? I think it is. Does someone want to speak to that? I think the bootcamp definitely covers AWS, I believe, right? At least when I was at the bootcamp, it was covering that, and I'm sure it's. Martina, are you here? Do you want to speak to that?
Yes, I'm not really sure that they're gonna cover it, but I can check into that and let you know.
Yeah, I'm pretty sure they cover that. And AWS, we covered a little bit of AWS back then. Not a lot, but you should definitely, learn a little bit on that, and grab this book. Data science on AWS, and they do great workshops and free workshops, 4-hour workshops on that. Fantastic way to learn stuff. Okay. Data science as an engineering practice. This is, I think this is, a lot of companies don't treat data science that way, but I think they should. And this is something that at least I try to adopt, because eventually I realized, hey, my upstream task is data engineering, my downstream task is software engineering. Well, what the heck, I need to be an engineer as well, and because otherwise they can't use my work, and I need to be able to engineer my work. And that's how I became a data science engineer, and building and managing my own data and model pipelines, possibly, and maybe just either or, building a data pipeline or building a model pipeline, depending on what project you're working on or the team structure, whatever. But the idea is that you want to become a better engineer rather than a better research scientist. If your title is not research scientist, of course, if you want to be, go for it. But if your title is not research scientist, then be a better engineer. That's the idea. Learn OOP Python for collaboration and production. Great book, Effective Python. And I think the second version just came out. Fantastic book, written by a Google staff engineer. And adopting IDE with .py files helps a lot. And that's how I nowadays do projects, write my code. And it's more trackable, compilable, less error prone, and more readable and workable by your engineering colleagues, and faster development speed. So this is what it looks like. And if you look at this, this magic command is how you integrate Jupyter kernel with .py files in VS Code. And this is where I test my code. Okay, I still need to test a little bit, but this is where I write my development codes. Okay, I don't do testing, and because in your Jupyter notebook, it's very easy to write one-liners and write your testing code, along with the development code, and you make mistakes and errors that could be potentially hard to detect. Okay, so if you separate the testing environment and the development environment, better practice, in my opinion. So yes, and also it's a good habit once you get rid of Jupyter Notebook, you start forming these great habits of writing longer pieces of code with lower bugs. Okay, and you start thinking how you can write better classes and design better code, right? Functions and classes. And you can reduce, if the more you do that, the more you can write longer code with lower bugs. Okay, that's a good habit to pick up. Is this editor brackets? What does that mean? Brackets?
No, brackets is an editor mostly that allows you to do two columns of coding.
Oh no, this is VS Code.
Oh, VS Code. Okay.
Yeah, Visual Studio Code. That's the it's, I think it's free. It's completely free versus PyCharm, which is, I think last time I checked, was $10 a month, but this is completely free and has a market to it. I don't know if it's completely open source, but it's owned by Microsoft, and it allows you to integrate Jupyter kernel with .py files. And again, Jupyter Notebook, there are workarounds, but Jupyter Notebook itself is not trackable by Git, right? So, but with this, .py files, they're perfectly fine with Git, right? So that's also helpful. All right, test-driven development. Test, you want to test your input schema, quality, data quality. We talked about data quality a little bit. Are there missing values? Test your feature distribution. Some of the ML pipelines tools would help you to do that. Test your version. You want to try to version your model, right? And I typically just version it with timestamp, okay? And test model outputs. Yes, you need to do that. Test performance. Yes. Test deployment environment. Yeah. So, and I will introduce a great tool. I don't know if you guys are familiar with. It's called TFX, TensorFlow Extended Pipeline, and it helps you a lot with this, with some of the components like evaluator and resolver, and infrastructure validator. Some of the components within the TFX library help you to complete these tests so that you don't have to write them yourselves. Okay, so building and owning your ML pipeline, that's an important topic now. Everyone's talking about ML ops, right? And there are different ways to do it. You can build ML pipelines with scikit-learn pipeline or TFX. And also I talked about SageMaker pipelines. So scikit-learn pipeline is a lot less developed, and it's just a class to call, but still great, right? But TFX is it's almost like entire ecosystem now underneath TensorFlow. And I was covering that TFX in the meetup I host. Okay, and you can orchestrate ML pipelines with Airflow, Kubeflow. Those are basically pipeline tools that you can write to schedule things. And Airflow is more general. Basically, a lot of data engineers would use Airflow to schedule cron job, right? That's a good way of using Airflow, but it obviously requires you to host it on a server. You can't run Airflow. You can't just run Airflow on your local laptop and just let it run. And also Kubeflow. And the idea is that you want to make your ML pipelines and models more reproducible, more resilient, more trackable, and you can, basically, there might be automatic model replacement in case of failures, alerts for retraining when model performance drops, and train serve skew. And that's an important topic. Typically, train serve skew could happen if you I mean, let me just tell you what it means if you don't know what it means. So basically that means, you know, you have a skew of performance or misalignment of performance. When when you train it, it says, I don't know, 90%. And when you serve it, it's, I don't know, 80%. And you realize, okay, shoot, something is going on, because when I serve the data, the model performance drops, 10%. I need to find out where that skew comes from. And, it could typically happen when you're serving your model in the production environment. Your data becomes a lot different than the data that you use to train your model. So that could be one reason that where it comes from. And so train serve skew, again, it's a very big topic actually, it is important and a challenging problem to solve. It could be, for example, what we just experienced, like COVID, right? That almost threw a lot of models off because no one has trained, at least a lot of companies, for especially the ones that get impacted, no one has trained their models, considering something like COVID, of that scale. And you wouldn't even have data for that. And when COVID happens, things hit and your model is off. All of a sudden, no one's buying things from you, or think people might be buying a lot of things from you, such as Amazon, right? People were going crazy on toilet paper. Well, guess what? No one was going to forecast extra amount of toilet paper being bought by people. And that's that. So inference speed requirements. And that is also in a topic, what's your inference speed requirements? Sometimes, for Twitter, you could imagine like, they would do something that would perhaps in a streaming fashion because tweets are constantly coming in. But the example I give from Zillow, right? And that's might not be, that particular use case might not have a very low latency requirements. It could be a batch prediction done, periodically. So you need to factor that in. Centralizing pipelines as a practice, ML ops engineer as a profession. I was just Googling it. A job, basically, let's look into Data Robots is looking for ML ops engineer. A strong background in Linux, distributed, containerized. So basically someone like Data Robot might want to hire someone who has had DevOps experience and containerized computing to be an ML ops engineer. So now it could be DevOps, professionals transitioning into ML ops. But hey, if you just want to be an ML ops engineer and just learn the technology and do a couple of projects, you might be able to get the gig as well. Regardless of the requirements. A lot of times the requirements in the technology fields are a bit unrealistic. A lot of times you will realize that it's not always the case like this. It doesn't mean you don't have a chance at all. Okay, it says 2 years plus working with containerization technology, 2 years plus building, maintaining production environment, 4 years with Python, backend engineer, ML ops, Azure ML ops engineer. That's Gecko. So Gecko, I guess, is using Azure. And yeah, so and it's very interesting. So I just said data science, learn data science with infrastructure. Data science lives with infrastructure. And in the end, if Geico is using Azure and you want to get this job, then you better know Azure ML Ops platform, versus AWS SageMaker. So roles and responsibilities, monitor components, CI/CD, machine learning concepts. So you need to understand a little bit of the machine learning concepts, machine learning lifecycle, some years of experience, and you need to have experience with Microsoft Azure machine learning components. Okay, so that, people are hiring ML ops engineer, and it's definitely a hot title now. Okay, so I give a quick example of a simplified TFX pipeline. And again, this is super simplified, and I just took it from TFX official tutorial. This is what it looks like: creating a pipeline with a bunch of components, and these components could be called CSV example gen. That means just you're ingesting CSV files with that component, and trainer component. So that trainer component is going to train your model within that component. And you push, you have a pusher component. So basically, once you're done with training, you automatically push it to a file system or serving model directory. So it automatically pushes that model to a serving directory so that you don't have to do it. And it's automatically pushed. And then you have a TFX pipeline class that, basically takes in all these three components. And let me just show you some of the other components. TFX. TensorFlow extended. So this is a TensorFlow extended page, and you have a bunch of great tutorials. I was just looking into this one as I'm trying to learn, a little bit of Vertex, which just came out. So Google Vertex platform just came out, and it's super cool. It also has feature store, I believe. And you can integrate TFX pipeline with Vertex. So and let me see. Yes, okay. It's also using a simple one. But look at what's interesting is to look at where it's pushing this to. So once you're done training, serving model directory. Once you're done training, it's automatically pushed to a Google Cloud Storage bucket, and your model, automatically gets served by perhaps a platform, by like Vertex platform, and then you don't have to do this. So it becomes a automated process, and that's what pipeline eventually does, right? It automates a lot of stuff, automates some of the tests for you and serving process for you. And this is what it means by ML pipeline. Okay. Another great example I want to give out is it's a scikit-learn pipeline built by practitioners. It's also class as well on Udemy by these two professionals, Soledad Gali and Christopher Semilab. They have a fantastic class if you're trying to learn more on the scikit-learn side. Okay, so this is what the GitHub looks like. Let me post that in channel. let me show you what a scikit-learn pipeline looks like. So eventually you want to package your every step of your data science development into something like this, calling the scikit-learn pipeline. And every data cleaning step needs to be refactored into a class using scikit-learn class. Let me show you that. Processing, yes, preprocessors. So using scikit-learn.base, base estimator and transformer mixing. And this is where you write a lot of pre-processing steps, but refactored into classes, right? So, and this is how it's done in a production level. You can have just one-liners, right? So it needs to be refactored and funneled into this pipeline. So in the end, then you have a linear model called lasso. And if you want to switch model, just change one line of code right here without changing anything else. And maybe you want to try a rich regression model, and then you prevent mistakes, right? And bugs and errors. Everything is pipelined through. Okay, so that's kind of what a production level data science project looks like. And there's, of course, testing that needs to be done. Tests, using PyTest, you can do a lot of tests. And you can also, let me see if there are data, I think there's data validation. This is in validation. And, you can do some data validation as well, which is pretty cool. And you have load pipeline, save pipeline, load pipeline, remove load pipeline. So the difference between this and TFX pipeline, as you can see, is that you have to write this manually. Scikit-learn doesn't offer that, but whereas TFX does offer all these components that you can use, like data generation, schema generation, validator, transformer, trainer, tuner, evaluator, infrastructure validator, and pusher. Eventually push it to the model, and you have inferer. These components are pre-built for you so that you don't have to build them yourself. Okay, so back to that, we're almost done. So feature distribution shift, data validation, and ML tests. This is what I meant by, sometimes you could have a feature distribution shifting, right? One feature could be shifting a lot. Again, after COVID, you would imagine a lot of these would shift. And you want to have, performance alerts and triggering a model retraining. So this should be done automatically so that you don't have to be like, oh, shoot, my model is not performing well. Let me take it down and retrain it. Well, you want to be alerted and you want to take it down automatically and replace it with something else, another model. Okay, and last but not least, I think this is a great philosophy to follow. Finish first, then iterate. Don't do this. It's, build a wheel, build two wheels, build a, base, then build an entire car. But instead, you should try to build a skateboard, scooter, bicycle, motorcycle, and car. In this way, you can constantly evaluate what you're doing and whether you're doing is good or not, or matching the business needs, and and you can constantly get feedback. Going back to the first slide, getting feedback from your clients, your supervisors, in this way, it's much easier. They can constantly evaluate that, so that when you get to this stage, things, there are no huge mistakes, I guess. All right, so I think that's pretty much all the slides. I don't know if this is the right, we can do a review exercise, but I don't know how, if this is the right, because I was expecting everyone to be a student. That's why I prepared this. But anyway, let me just open up to everyone to see if there are any questions. I know I've talked a lot, and there's tons of stuff in this. If you are relatively new to the data science field, that is certainly a lot of stuff to ingest and digest. And all comes from, a lot of stuff comes from my own experience, but a lot of stuff come from, what I've learned from other people as well. So.
Hi, Wenchang, can I ask a question?
Yeah.
Let's say just to start learning more about big data and data science, which programming platform would you recommend for starter, either R programming or Python?
Certainly Python. R is great for statistic analysis and visualization. But again, a lot of data scientists still use R, but what you realize is if you get better with engineering skill, which is what Python is for, Python is way much more engineering oriented. You want to get better with Python. And again, look back to the job description, right? Or from the survey. The fastest growing job are backend developer, senior data scientist, Python developer, DevOps engineer, data engineer. Top skills for data engineers, Python. Right? So does that answer your question?
Yes, thank you so much.
Sure. And SQL, right? SQL, no doubt. Python, SQL, and those are both taught by the bootcamp, so you don't have to worry about that.
Yeah, I was just about to mention that we are the only bootcamp that teaches both Python and R while studying here. Yeah. Yanis asks, what would have been the exercise that you have demoed? What?
Oh yes, it was the it was one that I was gonna show with for disease prediction for healthcare insurance companies. I've had a bit of experience with this, not a lot, but a little bit of experience, and it's a super practical problem, right? Healthcare insurance companies are trying to solve this problem, and they have perhaps solved some of them, and even I believe it was a government organization, or NIH, was giving out 20 million grant for solving a particular rare disease that kids will get after they get COVID. So I think I mentioned this during the last talk. This is a super practical problem to solve, in terms of predicting disease and having some prevention mechanism. It's a win-win scenario. The patient suffers less, the insurance company gets to save money, and that's a great way. It's a great use case and great, a big business need. to solve this problem. And there are tons of, because in the end, you're trying to predict disease for a particular disease, right? For example, depression. And, you're not trying to predict for everything. You can't. Then what about, heart disease? What about something else? There are tons of ML opportunities within this business use case. And the problem gets more complex as well, because you realize, hey, there's not just one type of depression. There's different types of depression, and there's some mild symptoms, there's some, it's all coded with ICD codes. So how do you handle that, right? So things like that all need to be considered, and ask questions to domain subject experts. Hey, what types of depression can you group together, and what types shouldn't you group together? That's a question I didn't know. And you need to ask someone who's in the medical field, and typically healthcare insurance companies do have employees who have had medical background. So identify who they are, talk to them, set up the business metrics, model metrics, right? So that was one review exercise. I mean, I kind of just answered it myself, but for the sake of time and yeah. All right, anyone else wanted to ask questions? Any other questions? Other references are here as well. Some of them are great books. I've read, let me see, I've read probably most of them, and maybe some of them I didn't read page by page, but I certainly read most of them, yeah. And those are great resources to get better on your data science skills. So.
Other questions for Wenchang? If not, thank you so much, Wenchang, for this super amazing presentation. It was really interesting, and I learned a lot myself as well.
Thank you.
And just as Vivian said, if you guys joined in late, that we are a data science bootcamp, and we are teaching both Python and R. Our next cohort starts on July 6th, so next Tuesday. And but we're gonna have more. So the next cohort is gonna start on September 29th, I think. And if you guys, if you guys need the notes, the slides, and the video recording, feel free to DM me your email, and Yanis has a question for you.
Yeah, so the community I'm in is called TWIMO. It's a great continuous education community after you're done with bootcamp. And so let me see if I can share my screen. 1 second, community. Yeah, it's, let me share this link with you, Yanis. Again, if you're working already, you want a place to learn stuff, and this is a great community. I have no affiliation besides just hosting the groups within the community. What I host is this one, building ML pipelines on every Wednesday. So from 6:30 to 8:30, yeah, PST. So, and there are tons of other groups So feel free to join us. It's a Slack-based community. And Twimo is a podcast plus a conference platform of ML or AI community.
Really interesting. I was about to ask that as well.
Thank you.
Other questions?
I have a question, if I may.
Mhm.
I was going to put it in the chat, but you know, I couldn't type that fast. Do you recommend honing skills and learning languages which are like object oriented, like Java or C++ mainly, or even C? Can somebody who wants to delve into machine learning benefit by learning object oriented languages?
Python is object-oriented programming. So the answer is yes, because you realize even if you know, machine learning libraries need to be engineered and written in an OOP fashion, you know, look into any TensorFlow models or scikit-learn models, right? So, but do you need to learn Java or C++? I don't think so. You don't need to do that. Python, master Python, you already have a job, and you have pretty solid paying job already. And it is the #1 programming language alongside with JavaScript. So if anything, I would suggest JavaScript outside of Python and R. So. And right, so because you know, JavaScript can allow you to build anything front end, and D3, you realize D3 is a more powerful visualization library. And you know, anything front end is more powerful when it comes to visualization, because when, you know, once you get to the web, anything web related, you can do pretty much anything. You know, websites, you can visualize anything, design anything. So, all right, I have a last question. Would one benefit from any? Oh,
No, it's the same question, but I did have one about do you know, like you know, MATLAB or MathWorks? It's the company that produces MATLAB, which is started as a scientific computing platform, but they have done a lot with machine learning.
yes.
And are you familiar? Would you recommend somebody to actually use that? And is that kind of a niche? Like if you do applications for engineering, for example, would then only then be useful?
MATLAB, it's more for research. And if you want to stay within the academia field and research fields, MATLAB could be a great tool, but it's not open sourced. I believe MATLAB is not open sourced. And as soon as you go into the corporate world, Python and R become way more handy, and Python even more so than R, because it's engineering, or it's more engineering oriented. Yeah, I have not had experience with MATLAB, unfortunately, but someone who has had, you know, mathematics PhD or physics PhD background would probably have that. But again, you know, do you want to be a research scientist? Do you want to be a data science engineer? Do you want to be a data engineer? Do you want to be an ML ops engineer? If you want to do that, you know, MATLAB might not be something that you want to try to spend too much time on. But, you know, if you want to stay within the academic field, go for it. And did you have jobs before you begin? Yes, I did. I was a real estate consultant, helping institutional clients to strategize and value and reposition their real estate assets. So I was analyzing a lot of real estate markets, dealing with real estate market data a lot for about 3.5 years. but I did not know programming, right? So I started from scratch. I started from zero, actually. I just started really hard at the bootcamp. I spent roughly 1,500 hours at the bootcamp. So including the pre-work, I spent probably 500 hours studying the pre-work, and just studied really hard during the bootcamp as well. And I came from a zero programming and mathematics background. If that answers your questions.
I have a question. How much, because I'm doing the pre-work right now, how much time, like week-wise, or if you really crammed in days, did you spend on the pre-work prior to the start of the boot camp?
Yeah, I probably started a couple months ago. I took a couple classes in the bootcamp already, not including in the bootcamp program, but I took a couple part-time classes physically in the bootcamp. And this is why NYCDSA is great, because it offers these physical classes where you can learn with a bunch of people. And that's where you get, a lot of the value from, right? When you pay this tuition. And I spent, probably 2-3 months, because I realized I came from a zero background. So I need to spend 2-3 months before the boot camp. So I just literally go to the boot camp even before the boot camp started. So I was friends with the previous cohort too, which is very funny. So yeah.
Yeah, and we are starting to go back on campus starting next Tuesday. So you guys are welcome. Like, just bring your vaccination card and stuff. Yeah.
Yeah,
So you
definitely go with the physical experience, learn with the teachers and all your data professionals in the same classroom. You just pick up way more, and that's what I've experienced. And a lot of us are still friends even till today. After 3 years, we're really good friends. We talk to each other a lot about data and constantly checking with each other. What's going on? What are you learning? What skills are you improving? And so on and so forth. Yeah. And what are you seeing in your position, right? That's very important. Yeah. To keep that network.
I saw that you did some group projects, right? How did you feel about those?
The group project was fantastic. And one of the group mates, actually both group mates, we're still friends. We're still talk to each other, and we fought day and night. We fought till like 2 a.m. in some of the days, and we took subway home together at 2 a.m. something like that. It was just fantastic experience to go through that with a couple bootcamp mates, and they're all doing well. One of them is working at Amazon Alexa as a research scientist, and one of them is a deep learning engineer working at a startup who just raised $100 million. So they're all doing very well. Yeah, very well. Better than me.
You're doing great too. You have like your own company, right?
Yeah, trying to start a startup. Still fighting. It's certainly very hard for a startup. Yeah, very hard to do startup. Yeah. Cool. So how realistic is it to do either the data analytics or data science bootcamps while working full time? I would say unless you're a Superman or Superwoman, it's very hard. and data science bootcamp is best done with like your whole mind and attention to it if you have not had previous experience. Okay, so if you come from a PhD background, you've already mastered Python, and you're just here to brush up your resume, go for it. And transition, go for it. You can do it part-time. So,
and we also offer career services once you graduate. So like if you're looking for jobs after your graduated from the bootcamp, like you can contact us and we're gonna help you like brush up the resume, interview, mock interview, and like networking in general.
Yeah.
And is the bootcamp physical location 24/7? Now that it's have COVID, I don't think so, but we are offering in-person classes. So the physical location is at 508th Avenue. So near Penn Station, I think. I can send you the website so you guys can check it better. And for working full-time professionals, we also offer like interactive distance learning. So you learn at your own pace. So like you can do it also 6 months. And so, yeah. Other questions? But yeah, thank you so much, Wenchang. It was a really great
Thank you.
talk. And
Thank you as well. Yeah.
sorry for the accidents at the very beginning.
Yeah, that was something certainly, and it's okay. We'll definitely move on from that, and we can just probably just restrict people from sharing their screens, or there's a choice you can make from, I think, button or option that you can choose to mute people or prevent people from sharing screens, and so that they don't. So
We're gonna check it out. And
absolutely.
yeah, if you guys want the notes, slides, and the video recording after I cut some parts, feel free to DM me your emails and I'm gonna send them out. Yeah.
All right. Sounds good. Thank you, everyone. Really appreciate it. Thank you, Martina, as well.
Thank you.
All right. Have a good holiday, folks.
Yeah, have a great holiday.
Yeah,
Bye.
thank you all. Happy weekend.
Thank you.
Thank you. Okay, I'm gonna stop the recording and